This content is introducing you to biosystems in the body, feedback loops, and the big lie. I'm taking you first to this image posted in response to an ostensible quote by Chief Seattle. Humankind has not woven the web of life. We are but one thread within it. Whatever we do to the web, we do to ourselves. All things are bound together. All things connect. And we have a lot of knowledge about this. We know from introducing species that don't belong into different ecosystems that introducing these species can cause the rest of the ecosystem to get out of balance. We know that when we plant homogeneous crops in a field that was heterogeneous before, the crops attract predators. The crops can thrive only with chemicals, herbicides, and pesticides. We know that when we cut down too many trees, the balance of oxygen available to us all decreases. We know that when we introduce too much carbon pollution into the air, the functions of all of the beings in that ecosystem diminish. We know that we're all interconnected, and we know that humans can play a role. As it is without, so it is within. Just as all of the earth is composed of interconnecting components in harmonious balance, so is the human body made up of interconnecting systems, linked in delicate balance to foster beautiful, harmonious inner workings. Just as we are a part of the larger web of life, so does this web of life persist inside our bodies, requiring the same delicacy and care. Let's draw a little more of a parallel. We can think of food as energy. Sunlight provides this energy for plants. The transformative molecule in plants is chlorophyll, the green coloring that allows the plants to convert sunlight into energy. When there's a lot of sun, the plant responds dynamically by reducing its chlorophyll levels. When sunlight diminishes, the leaves need more chlorophyll, and the leaves gain more green color. It's a feedback loop. The plant produces chlorophyll in response to the changing environment. Similarly, food serves as energy for our bodies. The transformative molecule in our bodies is insulin, facilitating the conversion of glucose, which is sugar that we get from food, into energy to feed our cells. When we eat a lot of food containing sugars or carbohydrates, the pancreas responds dynamically by producing more insulin. When we do not eat, the pancreas reduces insulin and relies on internal stores to fuel our cells. It is also called a feedback loop. Part 1, Feedback Loops and the Big Lie. What is a feedback loop? So the definition is the part of a system which some portion of that system's output is used as input for future behavior. In this case, we have something being built, whatever it might be. It's measured and monitored, and then we learn how well it works and change the building. Or build more in the same way, depending on the feedback that we get. The feedback impacts the future decisions. Here we have some examples of feedback loops. The first is an example of an intentional feedback loop. Imagine that we have a business and we want to improve our business, and so we seek input or feedback from our customers. Maybe it's in the form of comment cards, or maybe a survey, or maybe it's some sort of a questionnaire that we ask while individuals are in this business. But either way, we gather feedback and we analyze that feedback and prioritize it, decide which kind of feedback is the most important. We then make decisions about what things to increase or change in our business, and we take action based on those decisions. And it's a continuous cycle. We continue to gather feedback, to analyze it, to make new decisions, and to take actions, all in the hope of improving our business. We have feedback loops that are positive and feedback loops that are negative. So in this example, we have the intimacy feedback loop. So if we want to increase intimacy in our relationship, then we might risk vulnerability. That is, we might reveal something about ourselves, or show that we have a weakness, or cry, or reveal some flaw in ourselves. So we're making ourselves vulnerable. And what happens? Well, do we feel connected and safe with that revelation? If we do, that leads to an increase in intimacy, and the next time we'll risk vulnerability again, predicting that we will again feel connected and safe if we do so. And in this way, as each individual risks vulnerability, feels supported, valued, validated, safe, the intimacy between two people or more people becomes stronger. It's a positive feedback loop because each arrow represents a plus. We're adding and increasing the end result. A negative feedback loop is the opposite. Imagine that you are seeing if you can have a more intimate relationship, and so you risk vulnerability. And instead of feeling better, you feel worse. You feel less connected, less safe. Maybe you're teased and made fun of. And as a consequence, you feel less intimacy in that relationship and less likely to risk vulnerability again. And if this feedback loop continues, then the relationship becomes less intimate. An example of a negative feedback loop is this sleep example. If your sleep is disrupted, your fatigue increases. When you're fatigued, you have less ability to cope with stressors in a healthy way. This may lead to more stressors because you're unable to cope with the ones you have, and having more stressors in turn disrupts sleep. Continuing the cycle, the disrupted sleep increases fatigue, the fatigue diminishes coping ability, and the inability to cope disrupts sleep. And so this pattern continues and spirals and worsens unless we interfere with one of the elements of this feedback loop. We have feedback loops in nature. If we have an increase in, let's say, the rabbit population, that would lead to an increase in the fox population. More can be sustained. And then, if that rabbit population decreases, relocated, die out, too many of them taken by foxes, then we have a corresponding decrease in the fox population, and so forth and so on. And we see this in populations throughout nature, that populations in one group alters based on populations in another group. So now let's interfere with a feedback loop. Let's start with this customer feedback loop that we started with. Imagine that this customer feedback loop relies on evidence gathered from a comment box. And let's imagine that a competitor decides to give dishonest information. They learn that there is a particular salesperson who's very offensive to customers. But instead of revealing that, they put false information or disinformation into the feedback box and say that he's actually really great and they bought more because the salesperson was in charge. Well, that means that we may lead to bad judgment. Maybe the company will conclude that that salesperson's technique is effective. They'll make bad decisions. They'll promote that salesperson. Maybe they will train new employees in that particular technique, thinking that it's effective when in fact it's not. And so they'll get bad outcomes. The customers will be annoyed and maybe stop coming to the business. And let's imagine that we repeat this process again and again with different kinds of disinformation. What's eventually going to happen? Well, if the business doesn't fail, the business is going to stop paying attention to the feedback. They're going to disregard the comment box. Let's look at another example. If we interfere with the intimacy feedback again with dishonesty. So let's imagine that a new person in a place of business or in a school risks vulnerability by admitting to weakness. And others respond by making him feel connected and safe, but it's a lie. Really, when he's away, they make fun of him and joke at his expense. So at first he trusts that feeling of connection and safety, and he continues to increase his intimacy and risk vulnerability. But after a while, you know how things are. He begins to sense that something is not quite right. Over time, he knows, I am risking my vulnerability, and yet I find myself not safe. Maybe he gets wind, maybe he hears them talking in the back room, or maybe he sees something posted on a social media site. But somehow or other, he picks up on the fact that they're giving him a lie. Now, the consequences are worse. Not only does he not trust these individuals, but he trusts everyone less. He begins to second guess all of his judgments. If I guessed wrong about these people, have I guessed wrong about other people? Am I bad at reading clues? Are other people lying to me? And maybe this person's trust meter is altered, and maybe that alteration is even long-term and permanent. So in this story, the big lie, the dishonest feedback disrupting the delicate balance and beautiful harmony of the body, is the lie that comes along with simple sugars, such as those found in products, especially soft drinks, and products that are made of very little except highly processed sugars and carbohydrates. This brings us to part 2, feedback loops in the digestive system. The big lie? Yes, sweet, sugary beverages and foods are the big lie. They trick our bodies into believing there will be a lot of glucose or sugar to transform. In reality, though, the sugars from these products are simple, and they can be dealt with very quickly by the body. That's not what the body expects. So our bodies send out all the troops, insulin, to do the work of transforming the sugar into energy. But the work is completed very quickly. And so here are all these troops standing idly by, looking around for more glucose to transform. Nothing to do. They interpret this as a bad signal from the command center. All right, once in a while that happens, but again and again? We're going to look at this process once more. This is the feedback loop. Our blood sugars are constantly being monitored. The sugars enter the bloodstream because we've eaten something, and an appropriate amount of insulin is produced. Now, let's play a little trick on this beautiful process. Let's offer quickly digested simple sugar like a Coca-Cola to fool the body in thinking it's going to need to process a meal. The commander, sensing the input of all this sugar, says, incoming, incoming, need lots of troops. The troops come in, but this sugar's gone very quickly. There's nothing to it. And so the troops are standing around so bored, this commander doesn't know what he's doing. We've been standing here for hours with nothing to do. And so if this happens again and again, this commander begins to doubt himself. I won't make that mistake again. I won't be listening to that monitor anymore. Or maybe the troops. We're not going to listen to that commander anymore. He's sending us out here when we're not needed. Bad commander. Or maybe the monitor says, this is a bad monitor, better adjust it. When we sense a lot of sugar coming in, we better adjust it down. And so then, when some actual sugar comes in that's meaningful through a healthy meal, complex carbohydrates, the body doesn't know how to respond. We have beautifully adaptive innate systems or feedback loops in our body. How is it that we so often muck up the mechanisms? So this is an example of a feedback loop within the body. This is an autonomic example. It happens automatically, outside of our control. We have a normal body temperature that our body wants to be at. It's autonomic. We don't adjust that temperature. It happens to us. It's within our bodies. Homeostasis is our body's attempts to maintain that steady level. So ideally, your body kind of wants to be stable. We've already talked about this at the start of the term, and an optimal temperature for an individual that the body seeks to maintain, typically 98.6. I've read that it's decreased recently. And so if our body temperature falls, as happened in this case, it's cold outside, our blood vessels act outside of us so that heat is conserved. Our blood vessels constrict, our sweat glands do not secrete fluid, we might shiver involuntarily to generate heat, which warms the body. That will keep heat retained and we'll have a normal body temperature. If the body temperature rises, it's very warm, our blood vessels dilate, resulting in heat loss to the environment. Our sweat glands secrete fluid, and as the fluid evaporates, heat is lost from the body to the environment, and we have a normal body temperature again. So this is an example of positive and negative feedback loops. These two terms, homeostasis and set point, are important for you to know. Do we have control over these processes? We don't. But we do have control over some processes. If we have our falling body temperature, we do things. We drink a warm beverage, we put a blanket around ourselves, we turn up the temperature in the home or put more wood on the fire, and so heat is retained that way. So our body does some things for us, but we do some things for ourselves. If our body temperature rises, and we're rewarded for that with dopamine, we feel better when we do that, and so that encourages us to repeat that action. If our body temperature rises, maybe we go for a swim, we drink a cold beverage, we shed some clothing, heat is lost to the environment, we feel better, and we're rewarded for that with neurotransmitter dopamine. So we have some control over the things that happen within our body. This is a behavioral feedback loop. We've gotten feedback for engaging in a certain behavior that is beneficial to the body. An example of a feedback loop in the home comes from our thermometer, from our heat setting. So let's imagine that this is our furnace, and this is the thermometer on our wall. And the thermometer is where we give a set point. We tell that thermometer by setting it what temperature we want our home to be at, or a set point. Inside that thermometer is a switch, and when the actual temperature drops below the set point, in kicks in the furnace, the fire starts, and heat is produced. We can think of, within this metaphor, the thermometer being similar to the hypothalamus in our brain. The hypothalamus is a part of a brain that monitors a lot of levels of body function to ensure that they are normal. For some of our functions, we rely on a pituitary gland as a switch. For example, our sex hormones and growth hormones are triggered by the pituitary gland that's sort of like a master gland that triggers other glands to release hormones. Glands are like the furnace itself. They're the part of the body that store, produce, and release hormones, and they serve other purposes as well. But we'll think of them metaphorically as being like the furnace in our part of this metaphor. The hormone is the chemical messenger that produces change within the body when it's released from the gland. And that's analogous to the flame that the furnace produces. So homeostasis is the tendency of the body to maintain certain levels of maybe hormones, maybe temperature, maybe neurotransmitter, but to maintain certain levels of various things. And the set point is the level of whatever those things are that's optimal for a given body. And the heat is like the hormone that's produced. So when we're talking about the digestive system, the whole metaphor works except for that switch. We don't use the pituitary gland to work with the digestive system. Instead, the monitoring process interacts directly with the pancreas, and the pancreas is the gland that stores, produces, and releases insulin and glucagon. The hormones that we're talking about in this case, which are analogous to the flame, are insulin, which reduces glucose by transporting it to the cells. We talked about insulin already. and also glucogen, which is stored and added to our body in response to commands given through the pancreas, and it's given when our blood sugar is low. Homeostasis is our body's need to maintain certain levels of glucose to support the health of our cells, and our set point is the level of glucose in the bloodstream that is optimal for a given body. A healthy feedback loop relies on these autonomic processes. If we have low blood sugar, you can picture up here that these are little sugar molecules in the bloodstream, glucose. Then the pancreas releases glucogen. The glucogen is stored in the liver, and it has alpha cells that causes the liver to release the glucose into the bloodstream so that we have normal blood glucose levels and don't feel faint. So initially, if you're on a long fast for some reason, this process will be working by releasing glucose into the bloodstream, but we still will feel weak initially because there's some things that have to happen on a switch for us. But in the short term, if we're just hungry, we haven't had our dinner for some reason, then this will be happening, and so our cell health will be maintained through this glucose that is released from the glycogen in the liver. If we have a lot of sugar, then our body needs to deal with it. So the pancreas has beta cells that releases insulin, and fat cells that take in the glucose from the blood. And so once again, we're reduced to a normal or optimal level of glucose in our bloodstream. So to look at these hormones more closely, the insulin causes the body to take up and use or store the sugars in our bloodstream or the glucose in our bloodstream, either as glycogen in the liver for later use, or it'll use it right away. It'll take it up right away to help our cells with energy. The glucogen is another hormone released by the pancreas to dictate to the liver to break down glycogen into glucose and release it into the bloodstream. And what a messy set of words here. So we have glucose, which is the sugar in the bloodstream that we're being used immediately. The glycogen is the sugar that's been stored in the liver for later use. And the glucogen is the hormone that causes the glycogen to turn into glucose. And I'm sorry that's such a mess, and I'm not going to test you on it, but I think it's helpful to understand these terms. Now, one thing that's important is that walking or exercise improves the efficiency of insulin a lot. So we're going to talk about that in a minute. And let's see, this insulin, these red boxes that came in here, the red text, requires the pancreas to produce insulin. So the pancreas produces insulin. And in order for this step to happen, the receptors have to receive insulin. So there's some things that are going on here in this beautiful, delicate feedback loop. There's a lot of parts that have to listen to other parts. So regarding the exercise, my partner has a type of diabetes that has him needing to, he has type 1 diabetes, which means that we'll talk about this more later, but it means that his pancreas cannot produce any insulin. He was sick as a young man, and as a consequence, it sort of burned out the beta cells and alpha cells in his pancreas. So since the time he was a very young man, he hasn't had any naturally produced insulin. So every bit of insulin that he has to supplement. And so he wears a monitor. And it monitors at all times the levels of glucose in his bloodstream. So I've had the opportunity to learn quite a lot from this. And we've certainly learned that the levels of glucose in his bloodstream really drop when he has even a little bit of exercise. So ideally, most individuals' levels, if you were monitoring yourself, you'd want it to be around 100 is a nice level for it, but they can be between 80 and even 180 without being too big of a problem. And usually, if there's too much, if there's too much sugar, we add insulin. If the sugar is too low, then he has to drink something because he has to maintain his glucose at this level. But when he exercises, we find that he needs a lot less insulin. And because he has to take all of the insulin that he uses, we can look at these processes very closely. And we've certainly seen that even if we just walk for a half an hour after a meal, that same meal will require less insulin than if he hadn't eaten. Than if he hadn't exercised. So what I learned in looking up more about this to try and understand this better and support him is that it doesn't have to be intense exercise. If he has intense exercise, he actually has to stop all of his insulin and very often has to supplement with some fast sugar and some slow sugar in order to be able to have a long, strenuous exercise or a hike or something like that. But movement is the important part for helping the insulin do its work. So a 30-minute walk after a meal fairly consistently helps his insulin to convert into food. He needs less insulin. And it's especially beneficial, it can become a habit, because our bodies acclimate to different habits that we have and prepare for it. And so there's less disruption in the system. There's less potential for overreaction in terms of what the body will do. Strenuous exercise certainly has a place for other reasons, but as far as this mechanism in relation to insulin production and diabetes, just mild exercise, even a walk for half an hour, can do it. So a healthy feedback loop has autonomic and psychological processes. So we looked at the autonomic processes, which is the production of glucagon and insulin, but we also have two hormones that are produced by fat cells of adipose tissue. So ghrelin creates a psychological experience. It causes an individual to feel hungry. So when you feel hungry, oh, I should eat, that's the production of this hormone called ghrelin. Leptin is another hormone that's produced when you're full, and it causes you to have the subjective experience of being full or of satiation. Both work in the long term to motivate eating and the cessation of eating. So we have fat cells produce the hormone leptin. So if we have high blood sugar, then we have this leptin produce, and so we decrease the insulin secretion, causes you to feel satiated, and then we're back to normal levels. If we have low blood glucose, the stomach produces the hormone ghrelin that causes you to feel hungry. And in addition to having the production of the glycogen transformed glycogen into glucose, we have the promotion of fat storage. So that's a behavioral feedback loop. Also, so we have the psychological effect with those additional hormones, and then we have this behavioral effect. The glucose is low, so you've felt this feeling maybe when you're a little hungry. You feel edgy and irritable. I feel a little lightheaded when I'm like that. It's because the cells run out of fuel. And so you feel hungry, so you eat. The ghrelin kicks in, and your glucose enters your bloodstream and is distributed to cells, and so you're back to normal. So you get that dopamine reward. Likewise, if your glucose is high, your body devotes energy to digestion. You may feel sluggish and tired. You may feel full because you don't want to eat anymore. You have that sensation of fullness, and then the glucose is distributed to cells and your blood levels normalize and you're back to normal. So that's sort of a behavioral feedback loop maintained by dopamine. And do we have control over this? We do have some control over this if our hormones of satiation and hunger are working properly. We can make decisions about what we eat and when we eat. So we have a perfect cycle. What can possibly go wrong? Well, the first thing is type 1 diabetes, which is called juvenile diabetes. This is the one that my partner has that I was describing to you. No insulin is produced in the body. So this is the typical feedback mechanism, but instead of having the glucagon released, we take instead of the body producing insulin, we have shots. None of this works normally, so this person has to give a shot of insulin every time they're going to eat. For most people who are type 1 diabetics, the body neither produces insulin, doesn't have any beta cells, nor has the alpha cells that allow the conversion of glucogen. So they have to supplement all the time. So the sugar becomes like a medicine in the case of low blood sugar, and the insulin injections become a medicine in case of high blood sugar. And without it, the person would eventually die. Their body would not be able to, their cells in their body would not be able to receive any of the energy from the food that they eat. The pancreas doesn't produce insulin. But in the case of type 1 diabetes, the receptors function normally if they receive insulin. So there's no breakdown here. It's just that the pancreas doesn't produce insulin. This onset will be age of birth to the early 20s. The causes: a person's immune system attacks alpha cells and beta cells so that insulin is not released and glucogen cannot be utilized. So consequently, the body thinks it is starving no matter how much a person eats because glucose cannot be transported to cells. The excess glucose that's running around in the bloodstream because it can't be converted into energy is sent out in the urine and clogs up veins and arteries. So there can be some pretty big heart deficits. Eventually, untreated, this person will die of starvation. The treatment is insulin. Every single time food is eaten, every time carbohydrates are eaten that convert to sugar. People have to be careful not to get insulin shock, which is excess insulin due to low glucose. And that is type 1 diabetes. What else can possibly go wrong? So type 2 diabetes is called insulin resistance, and that is the one that is increasingly prevalent even in younger people now, which was pretty rare a few decades ago. And this one is a malfunction of the feedback loop that we've already begun to discuss a little bit. So the onset of type 2 diabetes is any age. Historically, it was more common at older ages, but now much younger. This emerges when part of the feedback loop goes awry. So something has gone wrong in the feedback loop. So the first possibility, and we talked about this in the metaphor with the troops earlier, the first possibility is that the pancreas stops listening to the hypothalamus and refuses to produce insulin. So you can see this is like a breakdown in the chain of command. Possibility 2, the receptors stop receiving the insulin produced by the pancreas. So it's like if the troops are sent out and the bloodstream refuses to let them in. Possibility 3, both of these could be happening, and there could also be other things going on as well. Maybe the pancreas isn't producing enough insulin anymore. This is a breakdown in this feedback loop somewhere along the way. The consequences are similar as for type 1 diabetes. Excess glucose in the bloodstream, it's sent out in the urine and clogs up the veins and arteries, and eventually it can cause loss of limbs, other symptoms, and early death as the bloodstream is clogged up with all this extra sugar. Causes we're going to look at a little bit later. And the treatment is very often lifestyle changes, and sometimes there is supplementary insulin if this is a severe enough problem. But the lifestyle changes in time can reset this feedback loop so it can be functional again. So before we look more at type 2 diabetes, we're going to look at a few other conditions of what can go wrong in this beautiful cycle. Prader-Willi syndrome is an example of a failure of the leptin system. Prader-Willi is a birth disorder due to an anomaly on the 15th chromosome, specifically on the paternal allele, and it has pretty severe symptoms, severe mental retardation along with other symptoms, but it also has an eating system. There's a failure of an individual to be able to feel full, a failure in satiation, and it's because the brain can't receive messages from the leptin. You'll recall that the leptin is the hormone that allows you to feel full. Well, this person never will feel full. And so they have to constantly monitor someone, generally because of the mental retardation components. Somebody very often has to monitor food intake for them because their body doesn't give them that feeling that we would have when we're full. What else can go wrong? Anorexia nervosa is interference in that reward system. So as glucose rises, blood vessels dilate, resulting in heat. Sorry, this is an old slide there. So if glucose is low, a person feels edgy and irritable because the cells run out of fuel. Typically, we feel hungry, but if you have anorexia nervosa, you don't eat, even though you're hungry. So you yourself disregard the ghrelin signal in your body. No glucose enters the bloodstream, but this person has switched their reward system, so they prefer that empty feeling to the full feeling. So they get a dopamine reward for something that is not beneficial to the body. So the body becomes emaciated and thin. But the person's reward system has been hijacked by the disease of anorexia, and so they no longer can respond to that body cue. They respond to the reverse body cue. And likewise, they might have an aversion to that feeling of fullness that they get when they have a lot of glucose in their bloodstream. This is called the restrictive type of anorexia. Likewise, if their glucose is high for some reason, maybe they've binged. Some people who are anorexic will binge and eat a lot of food in a short period of time. In that case, they might purge, exercise. They would have guilt and aversion. They would dislike that food, and the purging would give them a negative association with that feeling of fullness. So still, they won't get much glucose to their cells, but they're going to feel better psychologically because they'll have a relief of guilt. And so here again, the dopamine reward system is reversed, and the person is rewarded for something that's unhealthy for the body. And that's the binge purge type of anorexia. So what else can possibly go wrong? Well, we can have an abnormality of the reward system. Let's imagine that the person is dieting. They feel edgy and irritable because the cells run out of fuel. They want to eat, but they're having a diet. They're always dieting. They're on a strict diet, so they don't eat. So no glucose enters the bloodstream, and they maintain this tight grip, and they still don't eat, and so they get preoccupied with food. And they lose a little weight, they feel better about themselves, so they get a little bit of a reward, and then they repeat themselves. They're on the strict diet, and then all of a sudden they weaken, and they allow themselves to eat a cookie, a forbidden food. They give in, they binge, and they use all or nothing thinking, a cognitive impairment, and decide that since they blew their diet, they might as well eat the whole bag of cookies, so they binge, and they get a nice short-term burst of dopamine. But then they feel off about themselves, they're bloated, they're too full, they're unhappy. So they tape that over their mouths again, they're not going to eat anymore, and they repeat this cycle. The binges lead them to this guilt aversion, they get rid of the excess, they get a reward system again for that binge, for purging after they binge, and so they get this kind of repeat of this cycle of binging and having high blood sugar and purging, and then trying the diet, and then failing one time, and then starting the binge purge cycle again. That's called bulimia, and again, that's an abnormality of the reward system. And of course, the consequences of bulimia are fairly severe. There can be impacts on the brain. Of course, low self-esteem, shame, dizziness, anxiety, fear of gaining weight. Cheeks, swelling and soreness from the purging. The mouth, likewise, from the purging, there's a lot of acid in that can eat away at gums and teeth. The throat and esophagus can be sore, irritated, tearing, and rupture, again, from the vomiting. The muscles can get fatigued. The stomach can get ulcers, pain can rupture, and can fail to work in its normal process of emptying as it needs to. It can have an impact on skin as nutrients don't reach the body, abrasion of knuckles and dry skin. The ability of the body to reproduce will no longer be present. This body is no longer healthy, so they won't have the appropriate hormones anymore. This can result in intestinal problems like constipation, irregular bowel movements, bloating, diarrhea, and cramping. When we purge, our body fluids get low, so we can be dehydrated. We can have insufficient potassium, magnesium, and sodium. Our heart can be impacted with an irregular heartbeat. The heart muscle may be weakened or even heart failure. We can have low pulse and low blood pressure. And our blood can be anemic, not carrying enough of the iron that we need for the rest of our body. So fairly severe effects from this, even though it has a psychological root. So what about type 2 diabetes? What is the relationship between type 2 diabetes and food intake? Well, a normal process, we have the cell. Within the cell, we have glucose, and we have an open channel for glucose so that this blood cell can be nourished. The glucose is in the bloodstream, and there's the insulin doing its job of transporting it to the cell. Here we have a couple things that can come on. First off, the glucose perhaps can't penetrate the cell because the insulin receptors on the cell lose their sensitivity. They stop sensing it, they stop listening. And we also talked about the other possible mechanisms, which not just in the receptors, but also in the production of insulin. So it's a breakdown in that feedback loop. So this brings us to the foods that we eat. So beginning in the 1950s, we have a switch over into what seemed to be a relief of generally women who had to do a lot of cooking. And so instead of eating fresh foods, companies, industries began to take the foods, the beautiful foods that are produced on us, for us, and can them and process them and add a lot of sodium and sugar, and that's what you're reading about in your Moss book. And so all of these processed foods lack many of the fundamental nutrients that used to be in these natural foods and have a lot of sodium, fat, preservatives, and other additions that are non-beneficial to us. But many of us have been born since the 1950s, and we grew up knowing only these kinds of foods. We've forgotten the foods that come from the earth. We've forgotten what the good earth offers us in terms of foods. And as we have gotten homogenized diets of whatever the food industries choose to feed us, we no longer have the same diversity in our diets that we might have had, and we eat the same foods across the country regardless of the environment we live in, even though we may have our bodies dictating to us that we need different foods in a very hot climate than in a cold climate, or that we need different types of nutrients. And so we have been a bit taken over by the food industry, and that is what the Moss book is trying to show us. So the processed foods that are so dominant in our diets, excuse me, are based on industrialized homogeneous crops and large farm techniques. So the soil is fertilized with chemicals. The crops are raised all in what's called a monoculture, one crop on a large plot of land, and so it relies on chemical fertilizers and on pesticides and herbicides to keep the weeds and the insects out, which will otherwise devour a monoculture. Then these foods are prepared for us. So a factory chops, cooks, cans, heats, preserves, seasons, usually with chemicals, not the way you would do it in your own home. And because they want to sell their products, they appeal to people's natural preference for salt, sugar, and fat. Lots of additives. For example, in this chicken meal, we have white meat chicken. We don't know how those animals have been treated. Water, whole wheat flour, and cornstarch. And then we have a lot of these other products to ostensibly make it healthy. So for type 2 diabetes, there's a lot of addition of things that are particularly problematic, like simple sugars, which come both from juices and from like sodas that have a lot of sugar in them. Those are the quickest. They go immediately to your bloodstream and then they're gone, especially if you get pulp-free juice and that sort of thing. Very quick sugars, tricking your body. And foods like these are high in carbohydrates, which are converted into sugars. And so without something substantive behind them, something that takes high in fiber that takes your body longer to digest, these are all quick sugars that go rapidly into your bloodstream, just like the Grinch tricking you. And so this is the industry playing a trick on you, making it seem like this is a food that you would prepare for yourself that was offered by the earth. And instead, this is a chemical concoction offered by an industry trying to profit without an intention of making you unhealthy, but because they're trying to tap into your innate interests, they're just making you unhealthy by default, by serving in a paradigm that's dominated by the need to make money. Simple sugars, glucose, can be broken down rapidly in the body, but they don't lend any minerals, fiber, or nutritional value. Offer a quick surge of sugar. Have you ever had this happen to you where a little while after you eat a big dose of sugar, you just feel really tired? I've had that happen to me, and maybe you have as well. And that's because it just quickly leaves the body and leaves you feeling kind of heavy and weighed down and maybe sleepy, not alert, not at your best. Sedentary lifestyles exacerbate this problem. We have lives that don't demand that we do a lot of physical work anymore because the factories are doing it for us. And as such, individuals invest. So we have a life of processed foods where we're ingesting a lot of simple sugars, which look like food, but are broken down really quickly. Our pancreas releases a lot of insulin, which rapidly breaks down the surge of sugar and is then left to roam around the body. Eventually, the body thinks it's getting the message wrong, so it stops producing enough. And we generally aren't exercising much anymore that is going to help the insulin out, help it to do its work. And so the sedentary lifestyle exacerbates it. We mess up the feedback loop. We have a pretty significant increase in type 2 diabetes, and of course many who are likely undiagnosed at this time. The diagnosis of type 1 diabetes hasn't much changed because that seems to be related to like a problematic response to an illness. We project that if we continue on this trajectory, the rates of type 2 diabetes are going to increase even more. So obesity and type 2 diabetes, why are they on the rise? Well, first, there are genetic factors, and these are always a little ambiguous, but I have recently been reading a book that might be, that is really strengthening the linkage between the genetics and the native lands that people come from. An example given in the book is the lactose intolerance that is true of many people in the desert native to the desert Southwest, as compared to people who are native to, say, Europe, where a pastoral life herding animals was more traditional, and so the development of lactose tolerance was beneficial there, but not here, and so people here in the desert Southwest have a harder time digesting lactose. In this book that I recently read, it said like 99% of people who are from the native to the desert Southwest cannot digest lactose by the age of 7. And so that's a difference. But that's just one difference. And then he points out many other differences in the way that genetically people adapt to the foods that are available to them on their land, which means by inference that the conditions that might contribute to obesity and type 2 diabetes might be related to the inability to process foods that their bodies have not adapted to because of the environment in which people were born. There are societal factors. Sedentary lives I'm in a sedentary life right now at my computer for so many hours each day. I have to be pretty intentional about getting out. I'm glad I have dogs because we can walk far every day. Ready availability in fast food is a problem in many parts of the country. I don't think that that's a problem up in the Navajo Nation necessarily. I'm not quite sure, but I have a feeling that maybe that remoteness of many people is more of a problem there. There's advertising, things like 2 working parents. There are many societal factors that contribute to the food that's not beneficial. There are evolutionary factors. Our bodies, as you've read about in moss, are adapted to seek fats and sugars, but we're not to use them to abundance. It had been in distant history that finding these fats and sugars would be difficult. There are agricultural factors, change in crops and food supplies. So, for example, we have corn is ubiquitous. The FDA decided to support corn production, and if you look on the ingredients of many foods that we buy in this country, you'll see that corn is in some way a part of them, like corn syrup, if nothing else, as a sweetener, or the cattle and animals that are consumed in our country are fed on corn. And so if your body isn't adapted to tolerate a lot of corn, this might be problematic because this is heavy in the diet. And crops selected for high production also aren't necessarily easily digested. For example, we have a lot of people now, maybe you've heard of a lot of people who say they're gluten intolerant. Well, gluten is a natural part of grains, and in food it serves to bind together the bread dough so that it becomes like a dough and doesn't crumble and fall apart. And so we've adapted our crops to have a lot of this gluten in them. And by changing the balance within the seed of the crops, then we've changed the gluten levels. And so now many people have a reaction to gluten because it's too much and their bodies aren't able to tolerate excess of gluten. And some people even develop celiac disease, which is a more serious condition. And there are psychological factors. I'll tell you in a moment about the Schachter study, which suggests that some people can become insensitive to their body cues, no longer hear what their body tells them. We have food used as a coping mechanism, a type of addiction. Food can be a replacement for other things that might otherwise bring pleasure in a healthy way. And then mindless eating, eating in front of screens, or night eating. And I think in many places, social eating. You know, there's an obligation sometimes to eat what's placed in front of you, even if your body says that it's full. And so that can be a challenge as well. We can have part of societal factors being the food desert. So I think of this as a food desert. Even though there's a lot of things here that look like foods, I see there may be very little on these shelves that provides the healthy nutrients that a body needs. These are all highly processed foods, which usually have a lot of sodium and a lot of things the body doesn't need. Fast food, of course, is rife with high fats and calories and unhealthy foods. And then I add this picture because this is actually a picture from northern Arizona. And they talked about 2 counties up there being considered food deserts because it's so hard to get really healthy foods. That includes Navajo and Apache counties in northern Arizona. I don't know if you consider yourself to live in a food desert. The Schachter studies mentioned it just a little bit ago. He was looking at obesity and where there's some different psychological factors that contributed to it. And these, remember, primarily these people doing these studies are not working with Native people dealing with Native conditions. So this does not necessarily pertain to you if you are in either group, because they wouldn't necessarily be represented. Nevertheless, you can know about these studies at least and think about a study that you might be interested in. So this was just a study where people came to an office and there were almonds. They were in a waiting room and there was a bowl of almonds on the table, and some of them were shelled and some were unshelled with a nutcracker. And the people who were not obese ate 1 or 2 almonds regardless of whether there was a shell. but the people who were obese had a harder time limiting it. They would eat the almonds. All of them ate the almonds when they were shelled, and only 1 out of 19 ate when they were unshelled. So there was like the food that was easy to get to was easier for them to eat, and the people who were struggling with weight had different responses to those than those who were not. And then there was a clock study. People who were obese and those who weren't obese were invited to an all-day event, and the clock in the room was wrong, which indicated that it was dinner time early. And so if you're listening to your body, you would know when you're hungry. And if you're watching the clock, you'd have information in conflict with your body clues. And there were crackers, there's food available. And those who were obese ate twice as many crackers when the clock said 6 o'clock than when it said 5:20. So as soon as that 6 o'clock time came around, they ate. And the others had reverse patterns. If the clock said 6 and it was only 5:20, they would actually eat only half as many crackers, as if they were saving space for dinner, whereas at 5:20 they might have had more. So it's just a little bit of different eating habits and responses to cues in the world around. We also wonder if society could provide a defective feedback loop also, because the feedback loop from society suggests eating at many different times a day, or eating in social situations, or eating certain types of food like the donuts that are always present in the morning at work if you have that kind of a place. So we can think about the clues that we get from society as well. So what could cause people to cease to be sensitive to body cues? Well, you're ignoring your body cues because you can't or won't attend to them. The dopamine is reversed. You're paying more attention to meal times than to your body cues. And you're getting a feel-good response for doing so. We can think about whether we have control. And maybe in some days we don't have control. Like social obligations are very important. And if there's an obligation to eat, we don't want to disregard that. And so in that case, we might have to take action on the social obligations. In any case, it's especially important that we try to be aware of the cues of our body, and that takes some really conscious reminders. Some people can do things like have an app on their phone where there's a bell that rings intermittently, and then every time the bell rings, they just listen to their body. What is my body feeling right now? And they run their minds through their body, their stomach, their heart. What is their body asking for in a given moment? Practices like yoga are also pretty beneficial for body awareness. So I'll summarize with some concluding thoughts and then a couple of linking this back to where we started with the web of life. So we know that most bodies have the capacity to fully regulate and adapt to appropriate food intake through the feedback loops between the brain, the glands, and glucose. I have exception because in type 1 diabetes, that body lacks the capacity. In Prader-Willi syndrome, that body lacks the capacity, and there are some other conditions like that. Secondly, as humans, we have the freedom to choose what, when, and how much to ingest food. Thirdly, as a society, we have the luxury of enormous quantities of inexpensive, convenient, highly processed food and a lifestyle that requires very little exercise. And as individuals, we interfere with our own natural feedback loops. Sometimes we create adaptive feedback loops that reward appropriate food intake amidst a plethora of choices. Sometimes we create maladaptive feedback loops that reward minimal or excessive food intake or reward binge purge habits. So back to the web of life. We as humans are organisms within a web of life, one part of a harmonious natural whole. When we make careless choices in that environment, the balance is disrupted. This web of life continues inside our bodies, where the harmonious whole manifests inside. Here, our choices also disrupt the natural, beautiful biosystem. So I hope that this lecture impacted you in some way, but I hope that along with this is the realization that in many ways this was out of our control, out of your control. We were born in a time, many of us, where foods weren't available to us. Maybe you live in a food desert, but you didn't choose that. You didn't choose this world where the natural ecosystem is destroyed. You didn't choose to have cultural ways of interacting with the earth taken from you. You didn't choose to be constrained from ways of living that are harmonious with nature. But still, here we are. This life is just as it is. So we may want to be thinking, what can we do? What can we do to alter this trajectory? And remember that our bodies themselves are part of that big, beautiful web of life.